Hello, Algebra students. Today we're going to be covering the Unit 8 review. So up to this point, hopefully you've completed the rest of the packet. You should just be at the review when you're watching this video. Basically everything I write down, you should write down. But what I want you to do first is go through the review and see what you can answer on your own. And then just watch the video and just kind of get help on what you need help with and check your answers as you go. Okay. But again, everything I write down, you should be writing down. This will help you understand it the best. And hopefully you'll do well on the test. Okay, so let's go ahead and get started. The review starts on page 65 of your packet. But these first ones are just kind of like saying, simplify each of the following expressions. Be sure to show your work. So basically when you're simplifying one of these fractions, basically what you want to do is factor the top, factor the bottom, and see what factors cancel. So for example, in this first one, notice there's a 5x plus 15. Both of these terms, you can factor out a 5 from them. So this top part becomes 5x plus 3, like that. Because I'm factoring out a 5, that means I'm dividing both of these terms by 5. And when I do that, the 5 comes on the outside, and this is x plus 3. Notice if I distribute it back, you should get back to where you started. That's kind of how you can always check. If I distribute the 5 back in this parentheses, I should get this top again. Over, and then the bottom can't be factored. It's just x plus 3. But notice this factor x plus 3, and there's an x plus 3 on bottom. These factors you can cancel like that, and that gives you 5 as your answer. Okay, let's look at number 2. Similarly, you want to look at, okay, what can I factor out of both of these terms? What's the greatest common factor? So in this case, you could divide both terms by 10, but also they both have an x part. So you can factor that as well. So you can factor out a 10x from both of these terms. So that's going to leave you with x plus 2. And again, if you distribute this back, you should get back to where you started. And there's an x plus 2 on bottom. And just like the first question, this x plus 2 cancels with this x plus 2, leaving you with 10x, like that. For this one, number 3, we want to factor out, factor the top as well as factor the bottom. Now, hopefully you remember using this magic x to help us with factoring. But basically I'm going to do this top over here. So this is the top one. And then I'll do the bottom one over here. Okay. So for the top one, this x squared plus 3x plus 2, this top number, the top that you put up here is the constant. So that's going to be the 2. And then the middle term goes on bottom. Okay. Now this process changes a little bit if you have a number in front of the x squared. But a lot of these ones we're going to work with don't have a number in front of the x squared, just a 1 basically. So if you have it like that, where you just have x squared, you don't have like 5x squared, it's just x squared. Then you put the constant on top, and you put the linear part on bottom, the middle coefficient. And we're looking for two numbers that multiply to give me 2, but add up to give me 3. So two numbers that multiply to give me 2 and add up to give me 3. So that's 1 and 2. Notice they multiply to give you 2 and they add up to give you 3. Okay. So that means I can rewrite this top part as its factors are x plus 1 times x plus 2. So these basically tell you, these numbers here, tell you how this factors. So this trinomial factors as these two binomials. Similarly with this bottom, with the denominator, we're going to put the 6 on top here, 5 on bottom, and we're looking for two numbers that multiply to give me 6 and add up to give me 5. Two numbers that multiply to 6 and add to 5. So that's 2 and 3. Notice they multiply to give you 6, add to give you 5. So that means our factors are x plus 2 and x plus 3. Do you see anything that cancels? Hopefully you can see that this x plus 2 cancels with this x plus 2. So that'll leave us with the final reduced form of x plus 1 over x plus 3. Just like that. This number 4 is actually very similar to number 3. So we're going to factor the top and factor the bottom. So I'm going to put the top factoring over here. And we'd put the 8 on top and the 6 on the bottom. Again, we're looking for two numbers that multiply to give me 8, but they add up to give me 6. So two numbers that multiply to 8 but add to 6. So that's 4 and 2. Okay. So that means I could rewrite the top as x plus 4 times x plus 2. The bottom, with this bottom here, notice it's x squared minus 16. So for that, notice there's no middle term. There's no like, see how the top one had a middle term like 6x? There's nothing like that here. There's no something next to it, just an x, right? We have an x squared, but we don't have like just x to the single power here. But what you should notice is that x squared is a perfect square, and 16 is also a perfect square, and we have a minus here. So if you have a perfect square minus another perfect square, then this factors out. There's a shortcut to factoring that sort of thing. And again, it needs to be a minus, and these both need to be perfect squares. So what you do is put the square root of this first one, and that goes on the fronts. So what's the square root of x squared? Well, that's x. So x times x is x squared. And then what's the square root of 16? Well, that's 4, right? 4 times 4 is 16. And one of these gets a plus, and one of these gets a minus. All right, so that's how you factor this sort of thing. We call that a difference of two squares. So if this is a square, perfect square, and this is a perfect square, and there's a difference or a minus, then you could factor it in this way. Hopefully you could see that the x plus 4s will cancel here. And that'll leave you with x plus 2 over x minus 4. Okay. Hopefully this is nothing new. You've hopefully been doing this throughout the packet. Now, as far as this next one, it asks us to reduce this thing or simplify the fraction. But you see how this has top is x to the 7th and the bottom is y to the 9th? X's can't cancel with y's here because they are different numbers. So you could just leave it as is. This one does not reduce. This one does not reduce. So it's already in reduced form, essentially. But if these were both x's, you would subtract the powers, or if they're both y's, you'd subtract the powers. But since they're x and y, they're different variables, they can't cancel each other. All right, now for this one, we have x to the 4th, y to the 6th, and that whole thing is to the power of 2. So when you see a power to a power, what you do is multiply those powers. So this squared here goes to both of these here. So that's going to be x to the 8th, y to the 12th, because the squared goes to both these powers. And when you have a power to a power, you multiply those. Okay, I don't know why it's in this simplify or reduce with these other fractions, but yeah, that's when you see a power to a power, you distribute that and you multiply the powers. Okay. Multiply each of the following binomials to create a trinomial. Okay, so for this one, hopefully you remember how to multiply these types of things together. So what you would do is each of the terms in the first one multiply with each of the terms in the second one. So this x multiplies with this x, and then this x also multiplies with this 3. Okay, so x times x, that's x squared. So x times x, that's x to the power of 2, right? And then x times 3 is 3x, so plus 3x. Plus, now we want to multiply this 3 times both of these. So 3 times x, and then 3 times 3. So 3 times x is 3x, plus 3 times 3, which is 9. So that's going to be x squared. And we can combine these 3 x's together. 3x plus 3x, that's 6x, plus 9. Okay, so that's your answer. And you can go ahead and put your answer up here. Yeah. Okay. The next one's very similar. You're just multiplying x times x, x times negative 3. So x times x, that's x squared. X times negative 3, that's negative 3x. And then negative 3 times x, negative 3 times 3. So negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Okay. Hopefully you can see that better. Okay, so then that's x squared. And again, this negative 3x combines with this other negative 3x. That makes negative 6x. And then plus 9 at the end. Okay, so this is basically this is the factored form, but when you multiply together, you should get that. Last one, number 9. X times x, x times negative 3. So x times x, again, that's x squared. Hopefully you know that by now. X times negative 3 is negative 3x. Then multiply this 3 times both these. So 3 times x and 3 times negative 3. So 3 times x is 3x. And 3 times negative 3, so that's a positive times a negative, that's negative 9. Here in this case, we can also combine the negative 3x and the positive 3x. Those actually cancel because they're opposite signs, right? So then we're just left with x squared and negative 9. So x squared minus 9. Okay. All right, so here we have some more factoring. Factor each of the following expressions by breaking into 2 binomials. So this is very similar to some of what we did in the previous part. We would set up with the magic x. So hopefully you remember from when we were doing these ones how to set up these x's, right? How to factor these. So again, this last number, 20, will go on top. The middle number goes on bottom, and you're looking for 2 numbers that multiply to give me 20, but add up to give me 9. So see if you can figure that out for a second. So what multiplies to give you 20 and adds up to give you 9? So hopefully you'd be able to find that that's 4 and 5. Okay, these multiply 20 and add to 9. So this factors as x plus 5 times x plus 4. And I want to emphasize here that the order doesn't matter, right? If you put x plus 4 first and then x plus 5, that's the same. That's the same thing. All right, let's try number 11. So what 2 things? So we want to put the negative 24 on top and negative 2 on bottom. So what 2 things multiply to give me negative 24, but add up to give me negative 2? So this one's a little bit trickier because we were dealing with negatives here, but we know that they're multiplying to give you negative. So that means one of these is positive, one of these is negative, because they need to multiply to give you a negative. All right. So in here, our answer is going to be 6 and 4. Now, one of these is going to be negative because we want to multiply to give you a negative. But which one should be negative? Well, in this case, the answer is the negative should be with the 6 because they need to add up to give you negative 2. But if this were a positive 2, the negative would go in with the 4 instead. So that's x minus 6, x plus 4. Okay. And you could always check. You could always multiply this back together, and you should get back to your original trinomial. You could always check that way. Is multiply these 2 together, and you should get this answer. For number 12 here, hopefully you remember that this is a perfect square and this is a perfect square, right? This is 6 times 6, or in other words, 6 squared, and this is a minus. So that's a difference of 2 squares. So the way we factor that is the square root of this, well, that's x, because x times x is x squared. And the square root of 36 is 6. 6 times 6 is 36. One of these gets a plus, one of these gets a minus. While we're on this topic of difference of two squares, let's go ahead and do number 15 next. Hopefully you can see that this is a perfect square, right? This is 3x times 3x. And this is a perfect square. This is 4 times 4. And we have a difference, a minus. So let's go ahead and factor that. So this would be 3x. And the other one also gets a 3x, right? Because 3x times 3x gives you 9x squared. And then the 16, 4 times 4 gives you 16. One gets a plus, one gets a minus. All right, number 13 here. So here, what would go on top when I'm factoring this? Well, the 2. The constant goes on top. And the negative 3 on bottom. So two things that multiply to give me 2, but add up to give me negative 3. So this would be negative 2 and negative 1. Notice they add to give you negative 3. And if you multiply them, that'd give you a positive 2. Now this one has a y as its variable. That doesn't really make a difference, but just it'll be y in our binomials as well. Y minus 2, y minus 1. And again, the order doesn't matter. If you write y minus 1 first, that's fine. This last one, number 14, is perhaps the trickiest one. And the reason why is because it has a coefficient in front of the x squared, a coefficient that's not 1. So in this one's case, the way we want to use the magic x is instead of just putting the 10 on top, we would actually multiply these together, and that's what goes on top. So these get multiplied together, and that's what goes on top. So in our case, that's 90 on top. 9 times 10. The middle term, the b term, goes on bottom. And it's kind of the same here so far. We want to look for two things that multiply to give me 90, but add up to give me 21. I believe that's 15 times 6 gives you 90, but they add up to 21. Okay. They multiply to give you 90, add up to give you 21. Now there's another step we have to do. Whenever you have to do this multiplication, there's also another step we have to do. So what we do is we would take 9x, and I'm getting that from here, over 15. And then we do 9x over the 6. And you simplify these like you would a fraction. So how would I reduce this one? Well, I could divide both these by 3. So that would give me 3x over 5. This one I could divide also both by 3. So that would give me 3x over 2. Right? Dividing by 3 gives me 3. Dividing by 3 gives me 2. So once they're reduced, that tells you your factors. So our factors are 3x plus 5, and then 3x plus 2. And again, you could always double check to make sure you did it correctly, because if you multiply these back together, you should get back to your original trinomial. Okay. These ones here, we're going to do some factoring here as well to find the roots. So solve for the roots from each of the following equations by factoring. So we want to factor these, and the root is just basically what causes the factor to become 0. Okay. In other words, a root is an x-intercept. So if you were to graph this one, you'd get a parabola, and the roots are the x-intercepts. So we're looking for the x-intercepts in this case. And we can do that by factoring. So let's go ahead and factor this first one, again using the magic x. Here the 20 would go on top and 9 on the bottom. What two things multiply to give me 20 but add up to give me 9? I think we've done this one already. This is 5 and 4. So that tells me the factors. I could rewrite this trinomial over here as x plus 5 times x plus 4. And again, it just says equals 0. So over here. Now, what you do is you set each of these equal to 0. So x plus 5 equals 0. And then x plus 4 equals 0. So you put each of these equal to 0. And we're going to solve each of these. So to solve this one for x, we subtract 5 both sides. So that gives me x equals -5. So -5 is one of the answers. Here, if I subtract 4 from both sides to get x by itself, that gives me that x equals -4. So one of the key things here is that you could always plug these back in to check. If you plug in -5 in for x, then you should get this result being 0. Same if you plug in -4 in for x, you should get that this result is 0. For this one, we want to look for a greatest common factor. Is there a factor that you can pull out from both these? Well, yes. In fact, you could pull out a 9x. That's your greatest common factor for these two terms. Once you factor that out, this will just be x plus 3. Again, I'm dividing both these terms by 9x. Now, you would set each of these factors equal to 0. So 9x equals 0. And then x plus 3 equals 0. Here, to solve for x, you divide by 9. That gives me that x is 0. Here, you'd subtract 3 both sides to get x by itself. So that gives you that x is -3. For this next one, number 18, hopefully you recognize that this is a difference of two squares. So we can factor it. So the first term is a perfect square. Right? We could write this as 2x times 2x. We could write this one as a perfect square. That's 9 and 9. 1 gets a plus, and 1 gets a minus. So what you would do is you'd set each one equal to 0. So 2x plus 9 equals 0. And then 2x minus 9 equals 0. Okay, again, just setting each of the factors equal to 0. And then solving for x. So here, to solve for x, the first thing we would do is subtract 9 both sides. Then, so that would give me 2x equals -9. Then divide both sides by 2. So that'll give us that x equals -9/2. Same thing, same idea here. To get x by itself, we add 9 both sides. So that'll give us 2x equals 9. Then divide by 2 both sides. So that'll give us x is +9/2. So those are your two x-intercepts, or the two roots. Same thing. For this one, number 19, notice this doesn't say equals 0. Like these all said equals 0, but this one says equals -12, right? So the first thing you want to do is you want to make it say equals 0. And the way we're going to do that is we're going to add 12 both sides. So that'll give us that x squared plus 7x plus 12 equals 0. So now it's in the form like we want. We want to have equals 0. Let's go ahead and factor using this big X. So 12 on top, 7 on the bottom. What two things multiply to give me 12 but add up to give me 7? So that would be 3 and 4. These multiply to 12 and add up to 7. So your factors are x plus 3 times x plus 4 equals 0. And then you set each one equal to 0. So x plus 3 equals 0. x plus 4 equals 0. To solve this, you'd subtract 3 both sides, giving you that x equals negative 3. Here, subtracting 4 from both sides to get x by itself gives you that x is negative 4. For number 20, this is similar. I want it to be 0 over here, so I'm going to add 100 to both sides of the equation. So that'll give me n squared plus 20n plus 100 equals 0. Using our magic x here, we'd put the 100 on top, 20 on the bottom, and we're looking for two numbers that multiply to give me 100 and add up to give me 20. So hopefully you would see that this is 10 and 10. These multiply to 100 and they add up to 20. So our factors would be n plus 10 times another n plus 10 equals 0. You could set each one equal to 0, but hopefully you can see that both of these will give you the same answer, won't they? Right? They're both the same equation. So I'm just going to solve for one on one of them. So that'll give me n equals negative 10. Here, this one gives you the same one. So in this one's case, it only gives one x-intercept. So if you were to graph it, it would have one x-intercept at negative 10, where the vertex just barely touches. The parabola just barely touches at negative 10 here on the x-axis. And so if it has just one x-intercept, then that x-intercept is also the vertex. That's an interesting thing. Okay. Number 21, we're going to go ahead and add 6 both sides to help us get x by its, or help us get 0 over here, right? So this will give us 3x squared plus 9x plus 6 equals 0. I want to point out that I can't really combine the 9x and the 6 here. I can't like, oh, that's 15x. I can't do that because this 6 doesn't have an x attached. So you just have to add it at the end as a constant. But if there was another constant here, you could add the constants. You can combine those. But the 6 is not like terms with anything here. So, all right. Well, one thing we could do is I might notice that all these are divisible by 3. So I'm going to divide everything by 3, divide this side by 3, and divide this side by 3. But that still gives you 0 over here. So I have x squared plus 3x plus 2 now equals 0. Again, dividing every term by 3. Okay. If you notice that every term is divisible by some number, you could always divide everything by that, essentially simplifying your equation. Okay, so now let's use our magic x. 2 on the top, 3 on the bottom. What two things multiply to give you 2, but add up to give you 3? Well, that's 2 and 1. So this would factor as x plus 2, x plus 1 equals 0. Set each one equal to 0 and solve to find our x-intercepts. Subtract 2 from both sides to get x by itself on this one. X is negative 2. Subtract 1 from both sides to get x by itself here. X is negative 1. Okay. Question 22. This one's actually very similar. What are the two x-intercepts for this quadratic function? Well, to find the x-intercepts, again, you just want it to be equal to 0. So x squared plus 9x plus 20, and we set it equal to 0. We can go ahead and factor this. So to factor it, and I think we've done this one already, right? 20 on top, 9 on the bottom, What two things multiply to give me 20 and add up to give me 9? Well, 4 and 5. So this factors as x plus 4 times x plus 5 equals 0. Again, finding the x-intercepts, we just set each equation equal to 0. So x plus 4 equals 0, and then x plus 5 equals 0. Solving for x on both of these equations will give us our x-intercepts, or in other words, our roots. An x-intercept is the same as a root. They're just synonyms. Okay, subtract 5 both sides. X is negative 5. So our two x-intercepts are negative 4, 0, and negative 5, 0. Again, if you replace all the x's with negative 4, you should get 0 as a result. Similarly, if you replace all the x's here with negative 5, you should get 0 as a result. So that's the one way you could always check your answer as well. Okay, this one's the same deal. So again, let's rewrite the equation, setting it equal to 0. So x squared minus 10x plus 25 equals 0. And this is going to help us find our x-intercepts. So we're going to set up our magic x, 25 on top, negative 10 on bottom. Two things that multiply to give me 25 and add up to give me negative 10. That's negative 5 and negative 5. Notice they multiply to give you positive 25, and they add up to give you negative 10. So that tells us this trinomial factors as x minus 5 times x minus 5. And we set, it says set equal to 0. Set each of these binomials equal to 0. And hopefully you notice that both these are going to give us the same answer, aren't they? We're going to add 5 both sides. X is 5. And this one would give you the same, right? So this one only has one x-intercept, and it's at 5, 0. So the graph, if you were to graph it, would be a parabola with its one x-intercept at 5, and it'd be something like that, where its vertex is its one x-intercept at 5, 0. Okay. All right. Well, I hope that made sense. Hope you're able to get through it without too much trouble. And if you're able to follow along and able to understand everything, then you should do well on the test. Well, with that, good luck on the test, and I'll see you guys next time. Take care.